Okay, so welcome to lesson 5 of sequences and series. So namhlanje sidiscussa i-arithmetic and geometric series. So kulama lesson adlulile sidiscusse i-arithmetic sequence, geometric sequence and a quadratic sequence. Sithe i-arithmetic sequence sibona ngokuthi sine common difference. I-geometric sequence sibona ngokuthi sine common ratio. And then i-quadratic sequence sibona ngokuthi sine second common difference, right? So namhlanje sizokudiscussa ama-series lapho isi-edda khona ama-term wama-sequences. So i-arithmetic series ilast edda khona ama-term we-arithmetic sequence. I-geometric series ilast edda khona ama-term we-geometric sequence, right? But ngaphambi kokuthi sithome kunama question engifuna ukuthi siwadiscusse. Ngizaba wabiza ngokuthi ma challenge question. So khona ama question engiwatholile, so thanda ukuthi siwadiscusse. Okay, I think yekiyo le question. So ngithole i-question ethi a quadratic pattern has a third term equal to 2, a fourth term equal to -2, and a sixth term equal to -16. Calculate the second difference of this quadratic pattern. Okay, so masifunda i-question le ikhuluma nge-quadratic pattern. Mina-ke nangiku-exam, the moment ngizwa u-quadratic pattern ngizocabanga ngale formula yaka Tn is equals to an squared plus bn plus c, right? And then bathi a quadratic pattern has a third term equal to 2. So lokho ngitshela ukuthi T3 is equals to 2. And a fourth term equal to -2. Lokho kungitshela ukuthi T4 is equals to -2. And a sixth term equal to -16. Lokho kungitshela ukuthi T6 is equals to -16. Right? So bathi calculate the second difference of this quadratic pattern. So ukhumbule nasithoma sidiscussa ama-quadratic patterns sithe from ama-notes wethu but at least 4 numbers are needed to determine whether the sequence is quadratic or not. So you need at least 4 terms in a sequence to determine ukuthi leyo sequence is quadratic sequence or not. And then how will you know ukuthi i-quadratic sequence after sebakunikelile lawo le number ezi4? Uzokwazi ukuthi i-quadratic sequence ngokuthi ube ne-second common difference, right? So ku question yethu we have been given ama values wama term i3, sino T3, T4 no T6. So awuthi siwaliste ke lawo ma term, sino T3, T4, T5 and T6. So basinikele u-T3, basinikele u-T4, basinikele no T6. U-T5 asimazi, right? So sino T5 lana abakasinikeli, right? But then we have those 4 terms. We need at least 4 terms, remember, to work with the quadratic sequence. So but we now have those 4 terms. And then but from those 4 terms we can calculate the second difference, right? U-T3 basinikelile, u-T3 ngu-2, right? And then u-T4 ku-2, -2. U-T5 abakasinikeli, sizombhala as T5. And then u-T6 basinikelile ngu-16, right? Okay, so let me remove this. Okay, Okay. And as you know, T6, which is minus 16. Right, so what is calculated is second difference. Ukuze calculate a second difference, kumele sithome ngocalculate a first difference. Let us go ahead and calculate the first difference. So sizoba no T4 minus T3. So sizoba no T4 minus T3. It's minus 2 minus 2, which is minus 4. Sibe no T5 minus T4, which is T5 minus, T5 minus minus 2, which is T5 plus 2, right? Sibe no T6 minus T5. So sizoba no minus 16 minus 5, right? And then this is our first difference. So sesiya ku second difference manje. Calculate the second difference is T5 plus 2 minus minus 4. That is T5 plus 6. Right? And then sibe no minus 16 minus T5. This is T5 here. This is T5. Minus 16 minus T5 minus T5 minus 2. Minus 16 minus T5 minus T5 minus 2. Right? So sizoba no minus 2 T5 minus 18. Right? So is second difference yethu ngile. But calculate the second difference of this quadratic pattern. Because basitshela ukuthi it's a quadratic pattern, into esiyaziko nge-quadratic pattern ukuthi it has a common second difference, right? Mawuya kuma notes wakho uzobona ukuthi a pattern with a common second difference is a quadratic number sequence. So lokho kusitshela ukuthi because its second difference is common ku quadratic sequence, kusitshela ukuthi T5 plus 6 is equals to minus 2 T5 minus 18. Now we can solve for T5. Start to minus 2 T5 lo simulate ngapha siba no 3 T5. Start to 6 lo simusa ngalo minus 18 siba no minus 18 minus 6. Siba no minus 24, right? And then we can now solve for T5. T5 is equals to minus 24 divided by 3, that's minus 8. Okay, so no minus 8. Now sequence yethu nasibhala kuhle, sino T3, T4, T5 and T6. So lapha ku T3 sino 2, ku T4 sino minus 2, ku T5 sino minus 8 esiqeda ukumcalculator, and then ku T6 sino minus 16. Basitshela ukuthi calculate second difference lapha. Nasicalculate the first difference, siba no minus 2 minus 2, which is minus 4. Then nasithi minus 8 minus minus 2, so that's minus 8 plus 2, which is minus 6. Nasiba no minus 16 minus minus 8, that's minus 16 plus 8, that's minus 8, right? And then the first difference yethu leyo. Then nasiya ku second difference, sithi minus 6 minus minus 4, so it's minus 6 plus 4, so it's minus 2, right? Nasithi minus 8 minus minus 6, that's minus 8 plus 6, it's minus 2. So we therefore conclude that our second difference is minus 2. So uqedile ukuyisolve the question, right? And then another question engitholile ngizoyiletha just now. Okay, tisule la. Okay, so this is the second question engitholile. Okay, asifunde ithi the third term of an arithmetic sequence is 11 and the sum of the second and the fifth term is 26. Determine the constant difference and the value of the first term. Asifunde kuhle. The third term of an arithmetic sequence is 11 and the sum of the second and fifth term is 26. So the moment ngizwa arithmetic engqondweni nami ugijima uTn equals to a plus n minus 1 d, where a is the first term and d is the common difference, right? Because basitshela ukuthi it's an arithmetic sequence, right? So okunye basitshela khona bathi this arithmetic sequence, the third term of this arithmetic sequence is 11. So lokho kungitshela ukuthi T3 is equals to 11. And babuya bathi and the sum of the second and the fifth term is 26. So lokho kuchaza ukuthi nabahlanganisa is second term ne term number 5 bathola u26. So nabathi T2 lokho kuchaza ukuthi T2 plus T5 is equals to 26, right? The sum of the second and fifth term is 26. Lokho kusho ukuthi T2 plus T5 is 26. Okay, and then but it determine the constant difference and the value of the first term. The first term is T1. T1 ingu A in our equation. That is T1, and then that is the common difference. Common difference. So but he calculated the constant difference and the value of the first term. So ngamanye amagama bafuna ukuthi sicalculate u-A, sicalculate not D, right? So sisebenzisa le information le abasinikele yona ne formula ye general term of an arithmetic sequence. So because T3 is equals to 11, masithi T3 in our general formula lapha, in the formula of the general term, masithi T3 sizokuthola ukuthi we substitute u3 wherever we see n and get a plus, where we see n we put 3 minus 1 times d, right? So sizokuthola ukuthi sizoba no a plus 3 minus 1 is 2 times d, 2d, right? But then T3 is equals to 11. So la kuno T3 corner, we can just substitute 11, right? So this is our first equation, right? Okay, as calculated T2 using a formula a general term, must substitute U2 wherever we see n in our formula. Sizoba no a plus, where we see n we put 2 sizoba no 2 minus 1 sibe no times d. So this is going to be a plus 2 minus 1 is 1 times d is d, a plus d. So T2 it's a plus d, right? And then T5, as in calculator, substitute 5 where we see n in our general, in the formula of our general term. So it's over no a plus, where we see n we put 5, CT5 minus 1 times d. So it's a plus 5 minus 1 is 4 times d, it's 4d, right? But then ukhumbule ukuthi T2 plus T5 is equals to 26, right? T2 plus T5, T2 plus T5 is equals to 26. What is T2 plus T5 if we use this? So T2 plus T5 is 26, right? But T2 is a plus d, right? And then this is T2, plus T5. T5 is a plus 4d, that is a plus 4d, right? So this is equals to a plus a, that's 2a, d plus 4d, that's 5d. So T2 plus T5 is equals to 2a plus 5d. At the same time, T2 plus T5 is 26. So lokho kusitshela ukuthi 26 is equals to 2a plus 5d. So we'll call this our equation 2, right? So ukhumbule ukuthi sifuna ukusolve for a and sifuna ukusolve for d. Now we have two equations. Now this becomes a question of solving for simultaneous equations. So solving simultaneous equations, where equation 1 is that one and equation 2 is this one. So from equation 1, we can make a the subject of the formula. From equation 1, a is equals to 11. Now thathu u2d lo umlethe ngapha uzoba no, uzothola ukuthi a is equals to 11 minus 2d, right? And then you can call this equation 3, right? And then you will substitute equation 3 in equation 2, right? And then uzothola ukuthi, so wherever we see a in our equation 2, we'll put 11 minus 2d. So equation 2 is over 26 is equals to 2a, where we see a, we put 11 minus 2d plus 5d, right? So this becomes, this becomes 26. 2 times 11 is 22. 2 times minus 2d is about minus 4d plus 5d, right? So now tata u22 umletha ngapha uzoba no 26 minus 22, which is 4, and then ngapha uzoba no minus 4 plus 5d, which is d. So d is equals to 4. D is equals to 4. D sesimtholile, d is equals to 4. Now ukuthi sithole a, sizothatha d simsubstitute back to equation 3, right? So sizomsubstitute ku equation 3. So sizoba no a is equals to 11 minus 2d, but u-d sesimtholile ukuthi ngu-4, so sizoba no 11 minus 2 times 4, so this is 11 minus 8, which is 3. Therefore a is equals to 3. So equation le sesiphendulile, right? So equation yaka Tn ngizoyibhala kuphi equation yaka Tn. Okay, awuthi ngisule lapha phezulu spacing yana. Okay. So equation yaka Tn izoba so Tn is equals to a plus n minus 1 d. Sithola ukuthi a ngu-3, n minus 1, sathola ukuthi d ngu-4, so times ngu-4 la, so sizoba no 4n minus 4 plus 3, 4n minus 1. So i-formula yaka Tn is equals to 4n minus 1, right? So sisolvile na this question. Okay, now we have to move back to our notes. Okay, now we're back to our notes of arithmetic and geometric series. So sithe series, it's when we are adding the terms of the sequence. So in arithmetic series, it's when we are adding the terms of an arithmetic sequence. In a geometric series, it's when we are adding the term of a geometric sequence, right? So let us read through this. When we add the terms of a sequence together, we form a series, right? We use the symbol Sn to show the sum of the first n terms of a series. So Sn is the sum of the first n terms of the series, right? So Sn is equals to T1 plus T2 plus all the way to Tn, right? So here is a formula for Sn for an arithmetic series, right? Sn is equals to n over 2 times 2a plus n minus 1d, where Sn is the sum of n terms, a is the first term, n is the number of terms, and d is a common difference, right? So they then follow with a proof of how they arrived to this Sn formula. So this guy here, Uti, this proof must be learned for exams, right? If you read through this proof, uzobona na ukuthi iyenza isense the way by structuring akhona. I can create a separate video if mhlambe i-proof yale formula yaka Sn ya confuser. Just let me know if you confuse her, then I can create a video explaining how they derive this formula for Sn. So yeah, so if we are confused, i-proof lena ngazise lapho ku WhatsApp ukuthi ya confuser ungitshela ukuthi usitaka kuphi, and then I can create a separate video and derive this formula yaka Sn, right? This proof must be known for e-exam, and this guy, just a reminder. Okay, so now that we have a formula yaka Sn and it is available go formula sheet, right? Mina engizokwenza ukuthi ngidiscuss this example. Okay, so yeah, now we'll discuss the example. If you prove your confuser, just let me know, so we discuss in a separate video. Okay, let us create space for the example. Okay, so Ranabati determine the sum of the first 20 terms of the series 3 plus 7 plus 11 plus all the way to infinity. No, not to infinity, to term number 20, right? So determine the sum of the first 20 terms of this series. So one thing okumele check if uthola equation like this one, and for sequences as well, ukuthi ucheck ukuthi udila nge-arithmetic or nge-geometric sequence or series. Ukuthi ukhona ukubona ukuthi udila nge-geometric series kuzomele nge-arithmetic series kuzomele ucheck for a common difference, right, or a constant difference. So sino 3 plus 7 plus 11 plus plus 15. So it difference lana 7 minus 3 uthola 4, 11 minus 7 uthola 4 again, 15 minus 11 uthola 4. So sine common difference u-d is equals to 4. Lokho kusitshela ukuthi sidila nge-arithmetic series la. Again, because it's an arithmetic series, so I will have to work with Sn is equals to n over 2 times 2a plus n minus 1 d, right? So a is the first term, 3, right? N 20, because this is the sum of n terms, but then thina bathi sifune is sum of the first 20 terms. So n is equals to 20, right? So into esele lana ukuthi uyenze ukuthi usubstitute these values kule formula yaka Sn. So uzoba no S20, wherever you see n you put 20 is equals to 20 over 2 times 2, a is 3, plus n, n is 20, minus 1 d, d is 4, right? Values pressili calculator yakho and get an answer. Okay, so I mean press the calculator, ngizobona 20 over 2, which is 10, times 2 times 3 plus 20 minus 1, which is 19, times 4. So the sum of the first 20 terms of this series, ngithola ukuthi it's 820. So this is equals to 820. Okay, it's 820. Okay, oops, sorry. Now we'll discuss question 2. Okay, now we're discussing question 2 of this example. Right, so question 2, but the sum of the series 5 plus 3 plus 1 is minus 216. Determine the number of terms in the series, right? So basinikele uSn, okay? So basinikele ukuthi Sn is minus 216. Sn is equals to minus 216. All right. The sum of this series abatsho ukuthi it's a geometric or an arithmetic series. So when kumele uthole ukuthi it's an arithmetic or geometric, so if we check for a common difference, you'd see with 3 minus 5 it's minus 2, 1 minus 3 it's minus 2. So in a common difference or a constant difference minus 2, therefore this is an arithmetic series. Okusitshela ukuthi sizodila ngale formula yaka Sn. N is equals to Sn is equals to n over 2 times 2a plus n minus 1 d. Right, where a is the first term, in this case a is 5, d is minus 2, n asimazi, n nguye simfunayo. So from this formula Sn basinikelile, so sizoba no minus 216 is equals to n esingamazi over 2 times 2a, which is 5, plus n minus 1 d is minus 2. Right, so this becomes a formula yaka solve for n. So now cross multiply lapha uthi minus 216 times 2 uzothola ukuthi uzoba no minus 413 equals, 432 is equals to n 2 times 5 is 10 plus, and then minus 2 times n, it's minus 2n, minus 2 times minus 1 is plus 2. Right, so lana sino minus 2n minus 432, sorry, and then minus 2n squared, let's distribute our n lo ngaphandle into the brackets, then 10 plus 2 is 12, so plus 12n. Right, and then sithathe all the numbers and bring them to one side. This is 2n squared minus 12n minus 432 equals to 0. Right, and then I'll divide that throughout by un, by u2 uzokuthola ukuthi zizoba no n squared minus 6n minus 216. 432 divided by 2 is 216 minus 216. Right, 216 equals to 0. Right, so in a quadratic equation we can factorize or use the quadratic formula, which is corner formula sheet. It's x equals to minus b plus of minus the square root of b squared minus 4ac divided by 2a. Right, and then yeah, so mina ngizosebenzisa i-quadratic formula izothi n will be equals to minus 6 plus of minus the square root of minus 6 squared minus 4 times 1 minus 216 right, divided by 2 times 1. So nangipressa ku calculator ngithola ukuthi n is equals to 96 plus the square root of 6 squared minus 4 minus 216 divided by 2. Thola ukuthi n is 18, n is equals to minus 12, right? Minus 12. But then n has to be a natural number since we describe a number of terms, right? So since n is greater than 0, since n has to be positive, n kwamela be positive, right? Because so n in our case it's a natural number. So choose n greater than 0. Therefore n is equals to 18. So ku-exam if uthola ama-solutions ayi-2 for n, choose the natural number and not the negative one. Also, if maybe une fraction in your solution, choose the one which is not a fraction. You'll get a mark for choosing the correct value of n ku-exam. Okay. So now there's an activity which I would like to request you to do on your own, and then see. Okay, let us make this a homework for you to do on your own. Okay, now we participate in our discussion, ukhona ukuthi uzi-assesse nawe, and then uphendule lama question lawa la activity 4. Do the whole of activity 4. Ngizokusenda out a PDF file or a picture enalama question. Do them as your homework, and then if you come across challenges you can ask me, and then sikhona ukuthi sidiscuss la ustaka khona, right? So do this on your own, right? Then I will move to geometric series now. So a geometric series, it's when we are summing the terms of a geometric sequence, right? So the formula for a geometric series is this one. It's Sn equals to a times Rn minus 1 divided by R minus 1 for R greater than 1, or Sn is equals to a times 1 minus Rn divided by 1 minus R for R less than 1, where a is the first term, R is the common ratio, and n is the number of terms. Again, this proof should be simple and you must learn it for your exams. If you don't understand this proof, let me know where you don't understand it, and then we can create a separate video discussing the proof for this formula. Ama-proof lawa ayi-2 kumele wazi for exam, le arithmetic sequence series and a geometric series. So this proof here, this one, yaga Sn equals to n over 2 times 2a plus n minus 1 times d. This prove yale formula le, and prove yala ma formula lawa 2 meluas for your exams. So we can discuss the proofs in a separate video. Melung jele, but first ukuthi okay, you don't understand this proof, nokuthi staka kuphi. Okay. So again, mina I'll just do this activity. I believe ukuthi the best way to understand a section yama number patterns, it's by doing as many questions as possible. most of the time ama-question wama-sequences and series ayafana, they just change a few things lapha nalapho ukuthi babone ukuthi batest i-understanding yakho. So if you understand ama-basics, it should be easy for you to answer any question from ama-number patterns and series, right? And then kuzoba nama-cases where ku-exam bacombine i-arithmetic sequence ne-geometric sequence endaweni eyi-one, right? That's where they will test your understanding. So in the next 2 weeks nasdiscussa ama questions, ama question paper. When we go through question papers from number patterns, you'll see ukuthi most of the questions ayafana, is just change a few things ukuthi test the understanding yakho, right? If a question is from number patterns and engasho ukuthi maybe ingaba i-challenge, it's when they combine i-arithmetic ne-geometric sequence, right, endaweni eyi-one. That's where it can be tricky. But then ama-question lawa amanye you should be able to answer. If you are stuck in any way, let me know la ustuck khona, ngikwazi ukuthi ngikusize, ngitargete ama-weak points wakho, right? I believe ukuthi you should be able to get full marks from a section yama number patterns. And most of the time you'll see when we discuss our question paper, most of the time our marks is about 20 marks, 24 marks out of 150 from number patterns and series only. So if you master this section, you'll be guaranteed to get at least 20 marks unayo ku exam, right? So if we are stuck anywhere in this section, let me know, senze sure ukuthi awusabi confused, right? So I'll go through this example, activity 5. Right? Okay, let us create space. Okay, so let's go through activity 5. But it determine the sum of 3 plus 6 plus 12 all the way to 10 terms, right? So you have a series. Abakutshela ukuthi what type of a series is this? Is it an arithmetic series or a geometric series? So you first need to check the type of the series before you can proceed no pendule. So it's 3, so it's 3 plus 12 plus 3, it's 3 plus 6 plus 12 plus so on. So you don't know what type of a series is this. That's what you first need to check. So let's say it's an arithmetic series. What is it's an arithmetic series, you'll first check for a common difference, right? So if it is 6 minus 3, uzoba no 3, but then if it is 12 minus 6, uzoba no 6. Immediately lokho kuyakutshela ukuthi this is not an arithmetic series. So if formula leya ka SN angeke uyisebenzise, right? Because this is not an arithmetic series. So this formula, you won't use it, right? So you won't use this formula because it's not an arithmetic series, right? So it is a geometric a geometric series. Okay, ukuthi it's a geometric series sibona ngokuthi sine common ratio. Ukuthi simove from 3 to 6, multiply 3 ngo 2, that's 3 times 2, which give us 6. And then ukuthi simove from 6 to 12, 6 times 2, which gives us 12. Ukuthi simove from 12 to 24, 12 times 2, which gives us 24. So our common ratio is 2 and our first term is 3. So now we can use this formula as Sn, right? A is equals to Rn minus 1 divided by R minus 1. Since R is greater than 1. If R was greater than 1, besizosebenzisa le ethi 1 minus Rn divided by 1 minus R. Right? So we can go ahead and substitute 10 because we summing this up to 10 terms. So lapha ku A we put 3, lapha ku R we put 2, lapha ku N we put 10 minus 1, siba no 2 minus 1, and then let's press a calculator. Isinikela ukuthi this sum is equals to 3069. That's 3069. Okay, that's 3069. So that was question 1. Moving to question 2. Moving to question 2. Question 2, but if 2 plus 6 plus 18 is equals to 728, determine the value of n. So basinikele Sn lapha. Sn is equals to 728, right? And then bafuna ukwazi ukuthi n kubani. So sine series, asazi ukuthi it's a geometric or an arithmetic series. So asithome ngokuchecka lokho. Let's check for a common ratio. If usithi 6 divided by 2, sithola 3. And then if usithi 18 divided by 6, sithola 3. Therefore our common ratio is 3, right? And A is 2. So because we have a common ratio, this is a geometric series, and R is greater than 1, which tells us ukuthi sizosebenzisa le formula yaka Sn equals to A times Rn minus 1 divided by R minus 1, right? So Sn basinikelile ukuthi Sn is 728, right? And then A is 3, sorry, A is 2, and then R is 3, N kuyesimfunako minus 1, 3 minus 1. So 3 minus 1 is 2, 728 times 2, 728 times 2, that's 1456. That's 1456, which is equals to 2 times 3n minus 1. Dividing by 2 both sides. So it's all 728 is equals to 3n minus 1. Therefore 3n is equals to 728 plus 1, 729. So what is solve for n? We need to say our exponential equation. We need to solve for n this way. 3n should be equals to 3 raised to some power. Kiyiphi power kumele raise u3 ngayo in order to get 729. So I usually do this by trial and error. So by trial and error, if I say 3 to the power 6, if I say 3 to the power 6 la, right? If I say 3 to the power 6, ithola u729. So n is equals to 6. If I say 3 to the power 6 ithola u729. So ngitshela ukuthi n is equals to 6. So yeah, that's it for this question. Okay, now there's sigma notation and there's infinite geometric series. So I think it's enough learning for this video. I'll create separate videos discussing a sigma notation and infinite geometric series. Okay, yeah, I think that's it for now. So if ukhumbule ukuthi you have an exercise or a homework which is activity 4. So I'll send these questions to you. Do them. If you get stuck somewhere, send me a question on WhatsApp and tell me where ustaka kuphi, ungitshele nokuthi what is it that you are not understanding. So ukuthi manje explainela ngikhona ukwazi ukuthi okay yini leyo kufanele ngichaze kuhle, right? Okay, so yeah, I think that's enough for this video. Okay.